Assalamualaikum and a very good day to Dr. Asri, our lecturer for Design for Quality and Reliability. Today, we are going to present the reliability project consisting of group members Emmanuel, Lukman, Arif, Hafizi, and me, Wan Azlizam. So the company scenario is that we are currently facing critical issue regarding the decline in product reliability and reputation, resulting in customers switching to rival competitors. So the company's top management has instructed all engineers to prepare a comprehensive report addressing this issue. So we're choosing a company called Auto Precision Inc., which is our fictional company, and the product will be the Precision Drive Sedan. So reliability analysis is the field that focus on principles of reliability engineering to ensure that a system is performing its intended functions without any failures. Key concepts of reliability analysis includes reliability, failure, mean time to failure, failure rate, and reliability function. We've chosen 500 hours. Why? It's because usage patterns, which represents a common optional period, maintenance cycles, initial performance, early detection, and plan and resources.
Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present to you about reliability analysis using MTTF for car components. There are 10 cars components altogether: engine, transmission, battery, brakes, tire, alternator, fuel system, suspension, exhaust system, and cooling system. To calculate the reliability, we should have reliability function and MTTF. For reliability function, RT equal to exponent the power of negative lambda and T. To calculate the MTTF, we equal to 1 over the failure rate. So this is the calculation for engine and transmission. For the reliability over 500 hours, for engine we got 0.7, while for transmission we get 0.6. For battery we get 0.6. For brake we get 0.7. For tires we get 0.5. For alternator we get 0.7. For fuel system we get 0.7. For suspension we get 0.6. For exhaust system we got 0.7, and for cooling system we get 0.6. So these are the summary of the reliability system over 500 hours. We could see the 10 components of car, which are engine, transmission, brake, battery, tires, alternator, fuel system, suspension, exhaust system, and cooling system. In this particular summary, we could see that brake is the highest reliability, which is 0.7788, while the lowest is the transmission, tires, 0.5354. So we can conclude that the tire is the lowest reliability of all the components, the car components. So thank you.
So for my part is discussing about reliability block diagram, or we call as RBD, for 10 components in a vehicle. So basically, what is a reliability block diagram? RBD is a graphic representation of a components of a system and how they contribute to the system overall reliability. Each block in diagram represent components or part of the system, and in the reliability block diagram, or RBD, we have two types of connection, which is a series connection and a parallel connection. So series connection, all the components are connected one and another. If the component fails, that means overall system will fail. For the parallel components are connected parallel, the system can still function as long as at least one component in parallel is working. So in the calculation for RBD, so as we can see, the red color is represent parallel A, and then the blue color is represent series B, and the green color is represent series C, and the purple color is represent series D. So firstly, what is formula for parallel path? Okay, you can see below the slides the formula for parallel and series for the path. So for the calculation part, we have to calculate the parallel path, which is the red blocks. So we represent as RA. So RA we get 0.9046, and then calculate for RB. So for RB we get in series is 0.1753, and then we times RA to RB and we get RAB 0.1586. And then we moving to calculate RC. RC is a series, and then R engine and R fuel we times together and we get RC is 0.5449. In parallel, AB times C, we calculate both, and then we get RAB times C in parallel 0.6171. And then finally, we get R series AB times C times D, and we get the answer for RS is 0.3303, which represents the percentage of the reliability is 30%. So basically, in the automotive industry, 30% reliability we can consider as a low reliability. So how we can improve the reliability? So to improve the reliability in automotive sectors, we can make several strategies for the improvement. Firstly, through the testing under the various environmental and stress conditions to ensure the components can withstand with real scenario, is the first method we can implement to improve the reliability. Then, the regular maintenance, including a scheduled inspections and preventive maintenance, can help to catch potential issues earlier and replace the parts before it fails. That's two methods can make the improvement for the reliability for the automotive parts. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Fizibah Muhammad Najib. I will be talking about weak link analysis on our component, which is tires, battery and transmission. First, the shortest average lifespan is tires with 800 hours. The high failure rate suggests that tires are subjected to frequent wear and tear due to their constant contact with varying road surface and condition. Secondly is battery with MTTF of 1000 hours. This is indicative of the chemical and environmental factors that affect battery performance over time. Finally is transmission with MTTF of 1200 hours. The transmission system, while more reliable than tire and batteries, still exhibit a significant failure rate. This is likely due to mechanical stress and complexity of the component. Next is root cause analysis report, which is why this problem happened on our component. First is for tires, we have to design and material and usage condition. For design material, design of tires, including tire patterns and sidewall strength, may not be optimized for durability. Materials such as rubber, compound, must balance flexibility with resistance. For the usage condition, tires are exposed to various road conditions, including potholes, debris, and weather extremes. Incorrect inflation, overloading, and lack of regular maintenance exacerbate wear and increase failure rate. Second is battery. The reason is chemical degradation. Batteries degrade over time due to chemical reaction within the cell. This process is accelerated by factors such as overcharging, deep discharging, and frequent charge cycle. Second is environmental factor. Extreme temperatures can significantly affect battery life. High temperature increase the rate of chemical reaction, while low temperature reduces the ability to hold a charge. And finally, for transmission, mechanical stress. The transmission system experiences continuous stress from engine power and load charge. Gear wear, bearing failures, and fluid degradation contribute to transmission failure. Finally, lubrication issue. Adequate lubrication is crucial for the transmission moving parts. Lack of proper lubrication can lead to overheating and increased friction resulting in component. So that's all from my part. I will give it to the next person. Thank you.
For the action plan for the tires is to enhance the tire design material to improve durability and wear resistance, and to implement regular maintenance checks to monitor condition and ensure proper inflation, and develop and promote proper inflation practices among the users. So the responsible parties would be tire manufacturers, the maintenance team, training department for educating users on the proper maintenance. And for timeline, it would be 6 months for redesign and material testing, and ongoing for regular maintenance and user educations. For resources that we need is R&D budget for design and material improvements, maintenance tools and equipment for regular checks, training program, and materials for user education. So this is the action plan for battery. So it's develop more durable battery technologies, implement proper charging protocol to avoid overcharging and deep discharging, and of course to educate users on best practices for battery care. And the responsible parties here would be the battery manufacturers, electric system engineers, and customer service and support teams, which can provide users with proper education. Timeline for this would be 1 year for developing and testing new battery technologies, and the immediate implementation of charging and user protocols, and this has to be done with immediate cost. For resources would be R&D funds for technology development, education material, and improved charging infrastructure to support proper charging habits. So next will be the action plan for the transmission, which is to enhance design of transmission component to withstand greater mechanical stress, ensure adequate lubrication, and by using high quality lubricants and implementing regular lubrication schedule, conduct regular inspection and detect and address early signs of wear and tear. Responsible parties would be the transmission designers, automotive designers, maintenance teams for ensuring proper lubrication and conducting inspection. Time frame for this, the timeline will be 1 year for developing and testing new testing new transmission technologies, and the immediate implementation of the necessary protocols uh, for better transmission. And then would be the resources would be R&D funds for technology development, educational material and program for user guidance, and of course improve the infrastructure for better support in the better support for transmission mechanisms.
So for the monitoring reports, we have periodic reports on progress and impact. So in the transmission, we have updates on status and action items. So we have project managers and engineering teams to track progress for the softwares. And quarterly impact assessments include evaluation of impact implemented actions on reliability matrix. So we have data analysts and quality assurance teams to collect the tools and testing equipment for the software. So for the transmission, we have comprehensive reviews of all actions taken by senior management, project managers, engineering teams, and maintenance teams, and we're given detailed reports and presentations, and with stakeholders' involvement. So for that, that is all for our report. Thank you, and Assalamualaikum.